All right, so after that last video went viral with like 30 views, I decided, you know what? I'm going to make another one focused on the non-calculator portion, which you're taking tomorrow if you're watching this video on October 7th, 2021. All right, I'm going to try and keep it to around 20, 30 minutes because I never got to the lawn. All right, now we got River Dog Jenny here, but she is just chilling. Can we see? There she is. Look at that. She's on squirrel watch currently. What up, Jenny? Totally focused. She just ran after one. So we'll leave her to it, and we're going to get to some math, all right? So first one I want to go over is graphing. But we're going to graph this thing in standard, given a form in standard, or given an equation in standard form. So let's say we have y equals, oh my gosh, I'm still in the crazy colors. Let's see if I can change those. I guess not right now. X squared. Let's go with plus 6x. And then how about minus 4? All right, I found the colors. So first off, I want to find my vertex. And actually, I'm going to jot down a handful of things that we're probably going to ask you on a test. All right, here we go. So first off, I want to find my vertex. And at the same time, I'm going to find my x as a symmetry, right? So x equals negative b over 2a. And again, this is all non-calc. So negative b, opposite of b is negative 6 over 2 times a is 1. So I'm going to have negative 6 over 2 equals negative 3. Hopefully none of my neighbors are out here listening to me go ham on some math. Who knows? They might be. All right, so I get x equals negative 3, right? That's half point off if you don't put the x equals. So put that. Now for my vertex, I'll throw in a negative 3 here, and then I got to substitute it in. So over here, it's I'll write it up top. Negative 3 squared, oops, plus 6 times negative 3 minus 4. Now if you got to use your fingers, you got to use your fingers. I'm not going to use my fingers, okay? Back in grade school, a kid, we were sharing positives about each other, and the kid said, James doesn't count with his fingers when he does math. And I've carried that weight on my shoulders my entire life and have never felt like I am allowed to count on my fingers. Got to do it up here. All right, I got to live up to that kid's expectations of me from first grade. So negative 3 squared is 9. Then we've got negative 18 from that, so that's negative 9 now, minus 4. That's a real bummer because that's off of this. So you know what? I'm going to change this to can we do a plus 1? I'm sorry for changing this. Plus 1. So we've got, just so it fits, 9 minus 18 is negative 9, plus 1 is negative 8. Thank you for changing on the fly with me again. I'm making these problems up for you. All right, so negative 3, negative 8. Here we go. Cool. Awesome. Wonderful. My axis is symmetry. Boom. All right, next. We've got a couple options here. Let's see. Well, I can plug in some points, right? I can plug in for a t-chart, but it's also asking me for zeros. Let's just see here. How about this? Y-intercept. That's an easy one to grab from the graph. That's from the equation, 0, 1. Well, that's right up here. And then reflect over. 1, 2, 3. Boom. Right there. Love it. Fantastic. Wonderful. Let's just plug in another point because this thing's not factorable, so those zeros that I'm going to get are probably going to be kind of nasty. All right. So if I were to plug in, say, how about, so we got a t-chart going here. We've got negative 3, negative 8. How about negative 2? So if I plug in negative 2, I'm going to have 4 minus 12 is negative 8. Plus 1 is negative 7. And I can reflect that as well. I've got 5 points. That's beautiful. I could do more if we wanted, but this is enough to graph this thing. Make sure it's curved. It's not an absolute value. That's fantastic. It's graphed. But I am still asked for the zeros. So I'm going to erase that t-chart, make myself some room. So to find my zeros, we've got a couple options, okay? But let's say this, before we do the zeros, what if I asked you for this in vertex form? Okay, so if I wanted this in vertex form, I could go about it by completing the square, but because there's no leading coefficient here, and I have my vertex already, I could just do this. Y equals x plus 3 squared minus 8. Right, it's x minus h, and this is my h and this is my k. So I can just throw that in there. Boom, that's vertex form. Okay, so that's another question we could ask. Say, what's the vertex form of this, right? You had to find the vertex. Lots of things we could ask. Okay. Now back to the zeros. I have two options of finding my zeros right now. One, I can set my standard form equation equal to 0. And I'm going to jump over here and change colors. Okay, so I could say 0 equals x squared plus 6x plus 1. And that's not factorable, so I got to use quadratic formula. The opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So that's what x is going to equal. So I have negative 6 plus or minus, and then we have 6 squared is 36 minus 4 is 32 over 2. And now I have negative 6 plus or minus. I got to break that down. That's going to be what? 16 and 2, so that's 4 root 2 over 2. And I can reduce this further. Everything's divisible by 2. I can't divide it in the radical. I can only divide the coefficient outside of it. So I'm going to have negative 3 plus or minus 2 root 2. So these would be my zeros. And it's okay to write it like that because we're just asked for zeros where it crosses. I did not ask you for an x-intercept. We good. Now, I could also do this from vertex form. Check this out. I could set my vertex form equal to 0. And now I can add 8. I'm solving using square roots at this point, right? You were tested on that today, solving using square roots. So I got 8 equals, and then x plus 3 squared. I got a square root. So I get plus or minus the square root of 8. If I break that down, that's a 4 and a 2, so it's 2 root 2. Equals x plus 3. So I'll subtract 3, and you might actually already see this, what's happening here. I'm going to have x equals negative 3 plus or minus the square root, 2 root 2. Either way, I get the same answer, whether I set my standard form equal to 0 or if I set my vertex form equal to 0. I'm going to solve, okay? Lovely, wonderful, fantastic. All right, so that's one problem. Let's talk about one last thing here, because I could give you, say, an equation in vertex form, right, like this guy right here. And I can ask you about transformations. That was something where I had a lot of kids coming in today saying, hey, what transformations? I forgot about those. That's just asking left, right, up, down, whatever. So this would be going left 3 and down 8. Those would be some transformations. Cool? Now you might be wondering, well, what if there's a number out in front? And again, I'm going with a lot of examples. I'm kind of just rolling with it here, and I apologize if you're like, whoa, bro. What's happening? What if I had this? What if this was a different equation? What if I had like a 4 out front? I know that wasn't the case here. Well, this is a vertical stretch by a factor of 4. Had that been like a 1/2, it'd be a vertical compression by a factor of 1/2. The left 3 and the down 8 are still the same. Okay, so we've covered graphing, we've covered finding y-intercepts, finding our zeros, writing in vertex form without having to complete the square, right? Unless it says explicit, you got to complete the square. This situation, I can just plug that vertex into that form, which is nice. A lot of stuff here, a lot of stuff. All right, cool. Let me think of another problem. All right, let's do some stuff with some imaginary numbers. But before we do that, question for you. Notice the whoosh and whoosh, right? Our axis of symmetry, like if I gave you vertex form, you could also get your axis of symmetry from that, right? I could ask for the axis of symmetry from an equation like this, or I can ask it from vertex form. You need to be comfortable with both forms, okay? So there's a lot of questions we can pack in here, obviously, because there's a whole lot of stuff I have going on here, but a lot of things we can pack in. Okay, let's focus in on some imaginary numbers, complex numbers now. So this one's just asking us to multiply it out. Okay, so let's go with a lighter blue. I don't know if that's going to show up that well. I'll go with green. Okay, so 2 times 4 is 8. 2 times I is plus 2i. Negative 3i times 4 is negative 12i. And negative 3i times I is negative 3i squared. So we can combine some like terms. I also like dealing with this right now. This right here is going to be positive 3. So 8 plus 3 is 11, and then I have minus 10i. I am done. Cool, awesome, fantastic. Next thing, how about if we had like a 3i minus, actually I'll go with the real first. 3 plus 2i over 5 minus 7i. Okay? What do we do to rationalize? How do we deal with something like this to write it with no imaginary numbers in the denominator? Well, I have to multiply by what's called my complex conjugate. What is that? That is 5 plus 7i. So if I were to ask, hey man, what's that complex conjugate of something? You can write that, right? You know what to multiply this by. Remember, that is called the complex conjugate. I don't know if I spelled that correctly. I kind of want to look now. I did. Okay, awesome. One of my goals is to spell better. I want to spell words more better. That's not right. Okay, so let me multiply some things. I'm going to deal with the numerator. So we just did this, basically. Now we're just doing like 2 of them in one problem. So 3 times 5 is 15. 3 times 7i is 21i. 2i times 5 is 10i. 2i times 7i is 14i squared. All over. Now with this one, because I had the complex conjugate, I only have to worry about the first and the last, because the middle and the outer, the inner and the outer, are going to cancel each other out, because I'll have negative 35i and positive 35i. So don't even bother with it. So I have 5 times 5 is 25, and then I have negative 49i squared. Cool. Again, over here, I'm going to just take care of this whole thing. That's going to be negative 14. Now I can continue. 15 minus 14 is 1. 21 plus 10, that's going to give me 31i all over. Now this is, I should have just taken care of this too, because this whole thing becomes positive 49. And yes, I'm circling the addition, and I was circling the subtraction sign. Because I treat that all in one there, okay? And now I'm going to have 25 plus 49. That's 60, 70, no, 50, 60, 74. I can math. Yeah, I think that's good. Perfect, wonderful, fantastic. Okay, now, some will accept it like this. On the multiple choice, you would see it written like this. 1 over 74 plus 31 over 74. Nothing can reduce. Fit about to leave it like that. Okay? Wonderful, fantastic, awesome. Love it. Some of you might be wondering, hey, how's Jenny doing? Hey, Jenny, how we doing? This time you turned around, focusing on that squirrel. Ran right up the tree on her. I almost blew her cover when I was coming out here. Okay. Let us continue. Cool. All right, how about this one? Solve this. Well, if I look at this, I can't factor, right? Because nothing multiplies to 9 and adds to 2. So I can either complete the square if I really want, or maybe, you know what? I'm just going to go with quadratic formula. How about that? Okay? If you like completing the square, you'll get the same answer, but I'm going to go quadratic formula. So opposite of b, plus or minus the square root of b squared minus 4 times a times c all over 2 times a, which is 1. So that's what x is going to equal. Cool. All right. So negative 2 plus or minus. And now I have, you got to be very careful with your signs. I've seen some errors with signs and stuff like that. Here, it's going to be 4 minus 36. If this 9 was negative, then this would become plus. It would have been 4 plus 36. But because that 9's positive, we end up with negative 32. 4 minus 36 is negative 32 all over 2. Oh my goodness, we have a negative and a square root. I know how to deal with that. Negative 2 plus or minus. Now, let's break this down. 32, we've actually already done that. 16, 2. So the square root of 16 is 4, so that's 4 root 2. But I do have that I, so 4i root 2 all over 2. I can do some simplifications like we've done before. So I've got negative 1 plus or minus, and then we have, it looks like 2i root 2. So you might see it like that. You could see it as negative 1 plus or minus 2 root 2i. That's fine too. Either one of those we would accept. Lovely. A lot of times people like to write it as the first one, but I think technically speaking, it would be that one there. That's a plus bi. Cool. Awesome, fantastic, wonderful. If it couldn't simplify, it would have been, negative 2 over 2 plus or minus 4 root 2 over 2i, but obviously we were able to simplify it, but you could split it up in fractions like that if you were wondering. All right, I'm gonna come up with something crazy. Are you ready for this? All right, let's see, I've got this. square root of negative 49 minus plus. I'll be nice. 3i. Ooh, that's a good voice crack. 3i minus 1. And then, oh man, I'm going out of order here. I like it. 2i plus 1. Okay, let's see what happens here. Yeah. Oh wait, hold on. I'm just crazy. Okay, let's deal with it. Let's do it. Let's be awesome. Okay, so square root of negative 49. That's just, well, square root of 49 is 7, so it's 7i, right? Okay, cool. One thing down. Done. Awesome. I got to foil this whole mess together. So I have 3i times 2i is 6i squared. 3i times 1 is 3i. Negative 1 times 2i is negative 2i. Negative 1 times 1 is negative 1. And then I have square root of negative 4. So the square root of 4 is 2. So that's 2i, but we have negative 2i. All right. Don't misuse that negative with that negative and make it like positive and do weird math. That's not allowed. All right. As we know, this right here becomes negative 6. Okay, now let's put some i's together. We have a bunch of them. 7 and 3 gives me 10. Minus 2 gives me 8. Minus 2 again gives me 6. So I have a 6i going on. And then I have negative 6 and negative 1 gives me negative 7 plus 6i. That would be my final here. Okay? Awesome sauce. Fantastic. Let me think if there's anything else with imaginary numbers. All right, last one here. So I have 3 times and then the quantity 4 plus I squared. A frequent mistake from the children these days, and all of the days, is distributing an exponent into a binomial. You cannot do that. It will never be allowed. Not okay. I will scream, okay? So instead, what I want you to do is think of it like this. 4 plus I and 4 plus I. And then we can just FOIL it. We've done this a million times. All right, so I have 3 times, and then it would be 16 plus 4i plus 4i plus I squared. And now I have 3, and then we have 16 plus 8i plus 1. I guess I could have done that. So I have 3 times 17 plus 8i, and now I can distribute my 3. That's what, 51? Yeah, plus 24i. Cool? Do not make that mistake. It's the same if we were talking about, like, say, 2x plus 3 squared. It's not 4x plus 9. I have to write it out or think of it as 2x plus 3 times 2x plus 3, and then I need to FOIL. Okay? The same rules apply when we're dealing with imaginary numbers if we're expanding a binomial. Okay? I think that's enough imaginary numbers. Let's do a little solving now, and maybe some factoring too. A lot of people are on the struggle bus with factoring. How about a little factoring with leading coefficients? So just factor, okay? How about one of these bad boys? 3x squared plus 9x. Oh, man. All right. We forget about GCF, okay? You're like, what? Tooth turn? What? Okay. I can take out a 3, and I can take out an x, so I'm left with x plus 3. That's it. That's factored. We are done. Okay? Don't forget about GCF. GCF still loves you too. Okay? GCF loves you. Just like Jenny loves me. She actually moved a little closer. Let's see here. What up, Jenny? You just chilling by the tree now? Any luck with the squirrels? No? Hey, Jenny. What's up? Okay. Cool. There we go. There's your dose of Jenny. Let's go back to the math. All right. There we go. Now it's moving. I got an idea. Here we go. Here's a good one. So let's do a little solve here, mixing it up. How about if I had something like this? 18x squared minus 98 equals 0. Okay. So I got a couple options here. Okay, a couple options. I can either solve using square roots, or I can solve by factoring, okay? We've done a lot of solve by square roots. I'm going to go with the factoring method because I could also just ask this question without this and say just factor. Okay? So I'm going to do this in with factoring, but you can solve this using square roots. So first off, I'm going to divide by 2. Right? I'm solving, so I'm going to divide by 2. So I get 9x squared minus 49. Cool? Equals 0. All right. Now, what I'm looking at here is I have a 9, that's a perfect square, x squared is a perfect square, and 49 is a perfect square. So I can square root all those, which means I can split it apart in this fancy, fun way of 3x minus 7 and 3x plus 7 equals 0. Holy guacamole. Love guacamole. You know, some people don't get guac on their Chipotle. I know, it is an upcharge, but it is delicious. It just doesn't fit in my burrito. If I got a burrito bowl, it works. All right, moving on. 3x minus 7 equals 0. 3x plus 7 equals 0. So I'm going to get 3x equals 7. So x equals, 7 thirds. And x equals negative 7 thirds. Sorry, shortcut on that. Cool. Awesome. That's solved. Right? If it was asked to be in factored form, and I didn't ask you to solve it, it would be this, but you would have needed to have that 2 that we divided out when we were solving. You would have needed to have that in there in your final, okay? So that was cool. That was awesome. How about a little lead coefficient? That always freaks us out. I think it freaked us out probably on the calculator portion. How about just factor this? So just factor 4x squared. I'm going to go with a negative 8. And then let's say we got plus 31x. Oh my goodness, those are weird numbers. I don't like them. I don't care. All right. They don't like you either. Actually, they might like you. I don't know. So 4 times negative 8 is negative 32. And I want to add to 31. What two numbers are going to do that? Oh my goodness. It's the 2 easiest ones, but we overlook them every time. It's 32 and negative 1. Anything times 1 is itself, but we always forget about that with factoring. So let's get to work. 4x squared plus 32x minus 1x minus 8. Group them. Take out my GCF. 4x and then x plus 8. And then a negative 1 needs to come out in x plus 8. Perfect. So I have 4x minus 1 and I have x plus 8. Boom. That is factored. Awesome. Fantastic. Now, if it asked me to solve, if it was equal to 0 and asked me to solve, I'd just set them equal to 0 and I would solve, okay? Maybe time for one more or two. I'm going to take a look and see if I want to do. I'm going to think. One sec. All right, how about a little just regular old factoring? Ready? Are we ready? Just in case, just for good measure. Maybe this little confidence boost. You're like, hey, man, I know how to do that. Plus 8x, and then how about minus 20? What multiplies to negative 20 and adds to 8? I'm letting you think. I'm letting you think. You know what I'm saying? Hey, Jenny, do you know what multiplies to negative 20 and adds to 8? Nope. She's just a dog. She doesn't know. Okay, hold on. Let's see here. How about positive 10, negative 2? Awesome. All right, so if I was asked to solve, I'd get negative 10, and I'd get positive 2. I could also ask, hey, what's the sum of those, or what's the product of those, or what's the difference of those, whatever. Lots of different questions, but they all revolve around factor, okay? And then one last thing. Someone, Jenny just said, she's like, hey, dog, why don't you show them how to do this one via square roots, okay? Just for fun, just in case they maybe prefer that method. So let's go ahead and do that. So if I had 18x squared minus 98 equals 0, I could start the same by dividing by 2, and now I have 9x squared minus 49 equals 0. I was not sure apparently when I was trying that 0. So I got to get the x squared part alone, right? So 9x squared equals 49, divide by 9, and then x squared equals... I have 49 over 9. I can't simplify that. But if I square root on both sides, x equals plus or minus, well, actually, those are both perfect squares, 7 and 3. So, same answer. This time I had to throw in that plus or minus when I was solving using a square root, but we were all Gucci. Cool, awesome, fantastic, wonderful, cool. I think that's pretty dope. Yeah. Actually, wait, there's more. One that freaked people out on the review. I know they're like, dude, bro, how do I do that? Let's say we have roots of a quadratic equation of roots at, let's say, 3 and about 1/3. Sure. Well, let's write it in factored form and standard form. Okay? So we'll give both. So for factored form, it would be, well, let's see here. To get a root of 3, I would need the factor x minus 3. Because if I set that equal to 0, I add 3, I get x equals 3. Right? That's what this is saying. X equals 3. What's the factor to get that? Now, the 1/3 is a little bit trickier. Actually, I'm going to make it, yeah, 1/3. Actually, let's change this. I want 2/5. I don't know why. I just chose it. All right, I do have a reason, okay? I want a coefficient. All right, so 2/5. Well, I need to be dividing by 5 in the end. So that means I'm going to need a 5x, because if I set something equal to 0, at the end, I'm going to divide by that coefficient in front of the x. Now, that's a positive 2, so this is going to be a minus 2 here, so that I add 2, and then I divide by 5. And let's say it's an equation, so I'll just set equal to 0. So that is factored form. Now, if I'm asked for standard form, I just need to multiply this out. You guys have done that all the time, but you need to know what standard form is or what it's asking for. So x times 5 is 5x squared, and then negative 2x, and then negative 15x, and then positive 6, and that equals 0 still, so 5x squared minus 17x plus 6 equals 0. Awesome sauce. Wonderful, fantastic. All right. That's pretty dope. All right, last combo. Last combo mambo. Are we ready? Cool, awesome. Let's say I give you an equation or some information about a graph. I think we had one of these 4 or 5. I don't know. I can't remember the section. But let's say, Jenny, what's up? You ready? Ready to do this? Last problem? Okay, Jenny's ready for the last problem. All right, she's yawning. She's getting bored. Let's say we have write a quadratic equation in, let's say, we do vertex form if the vertex is, how about negative 2, 5, and then passes through about negative 3, 9. Okay, so I know my vertex form. Do you know your vertex form? I guess that's a better question there. Y equals a times x minus h squared plus k. Cool. And then, so the vertex, h, k, x, y is the point. So I can do 9 for my y, a, I don't know what that is. Then x is negative 3 minus negative 2 squared plus, then k is 5. Okay? So now I can get solving for a. So I got 9 equals a times, and that's negative 1 squared is 1 plus 5. Okay, cool. Subtract 5. We had a lot of 9s and 5s when I did these. 4 equals a. Cool, awesome. That's it. I didn't even have like a coefficient. If that was like a, this was like a 3, I would divide by 3 and I'd have 4/3 for a. But I don't. All right, so my equation is y equals 4, and then it's x minus negative 2, x plus 2 squared plus 5. Cool? That's vertex form. That gives us a moment here. One more time. Transformations. What the heck does this do? That is a vertical stretch by a factor of 4. What the heck is going on here? That's left 2. What the heck is going on here? That's up 5. No, these are all things we can do without a calculator. Alrighty, cool. And you know what? One more for good measure. I can't remember if we even did this. I don't know. All right, we might have done one already, but this is one that people struggle with. I was helping them with it after school today. The inequalities. We did that in 4.8, so it's, you know, right at the end there when we're all like, bah. All right, negative 3x, and then how about minus 15 is, let's say, less than 0. All right. So first things first, I got to factor this. And now people do this in different ways. This is just me, all right? But of course, my way is the best way. Not really. I don't know. If I factor this, I have x minus 5 and x, wait, this needs to be a 2. I know what I'm doing. There we go. Otherwise, it's not factorable. X minus 3, and I just said my way is the best way. I should not have bragged. Okay, so that, there we go. That right there is factored. X minus 5 and x plus 3. Apologies. This definitely needs to be the last problem. Then I got to mow my lawn. Never got to it yesterday. Okay? So we have x equals 5 here, and we have x equals negative 3 here, if we were to find it. I solve for them because if they equal 0, around that is where they are positive or negative. And according to this here, I want this to be negative. I want it to be less than 0. So let's do a little sign chart. 5. Of course, we got a little 0 action right here. Okay, so first off, if I were to graph this, that would be open and open because it's not equal to. And now I'm going to do some test points. So if I do some test points, I'm going to pick a number that is outside or to the left of negative 3. Hopefully that looked like to the left. I don't know if this mirrors it. But anyways, that's how about negative 4. If I plug negative 4 into this first one here, I'd get a negative number. Negative 9, but I don't really care. It's just a negative number. If I plug it into the second one, it's another negative number, right? Negative 4. And then, so that overall is positive. If I pick a number between these two, like 0 is really easy. The first one's negative, the second one's positive, so it's overall negative. I'm saying when I plug it in here and when I plug it in here, okay? 0 minus 5 is a negative 5. It's a negative. 0 plus 3 is a positive number. So overall, it's going to be a negative number. And then if I picked 6, I'd get a positive and a positive, so overall positive. Now, what does this want? It wants it to be less than 0. So that means my final answer here is that x is between negative 3 and 5. That is my solved inequality. And if I were to finish graphing this, I'm already in a different color, whatever, I'd shade between. Had it been greater than, I'd be going outside, and greater than would look like x is less than negative 3, or x is greater than 5. That's if it were this way in the original, okay? This is a what-if situation. Cool. Awesome. I hope you guys enjoyed. I know I certainly enjoyed. Jenny, did you enjoy? I don't know if Jenny enjoyed. Let's see here. Jenny, did you enjoy? We got a lot of pine needles around here. There's a giant evergreen if you saw earlier. I got to get rid of those too. Actually, I don't know how I'm going to do that. Anyways, have a wonderful day, guys. America Freedom, rock and roll, Costco. Riverdog Jenny on the gram, of course. Make sure you follow at Riverdog Jenny on the gram, right? She's part of this video too, so she gave up some of her time as well. See ya.